So far in our searches, to date no solar twin that exactly matches the Sun has been found. Let's be frank, it may never be found. The parameters of each individual star are so intricate that it seems unlikely. However, there are some stars indeed that do come very close to being identical to the Sun, and as such are considered solar twins by members of the astronomical community. Hi everyone, Vega here, and in today's video we return to our brightest star series to take a look at some of the most familiar stars of all, Sun replicas. So let's get to it. First of all, before we start today's video, I'm delighted to be back writing again. You folks may not be aware, but over the previous couple of months you've actually been watching videos I wrote back in March. This is because my work schedule in May and June is too much to be able to write videos and get everything else done. But from here on in though, the videos will hopefully be fresh off the press, so to speak. Also, one last thing before we get back to the Sun replicas that I feel I have to comment on given the surge in recent times. It seems quite apparent to me now just how much AI content there is out there regarding astronomical topics these days, all put together with polished transitions, all narrated by a perfectly spoken narrator. I'm not personally a fan of that stuff though, although you may be yourselves. And although sure I do use a few AI generated images myself, I hope you folks can appreciate that we are a small channel, but to paraphrase the great movie The Matrix, we're born free right here in the real world. The future may be the world of AI videos, but for now this is our time. Anyhow, back to the solar analogues, which is of course why we're all here. It came to my attention writing this video that it's probably going to be too long for one part, so the plan is to post the second part within a few weeks, and maybe join them together at a later date, depending on how well part 1 does. Let's first distinguish between twin and analogue. An exact solar twin would be a G2 main sequence star with a 5778 Kelvin surface temperature. It would be 4.6 billion years old, with the correct metallicity and a 0.1% solar luminosity variation. The chance of finding a star like that seems remote for the time being. So really what we're dealing with are solar analogues, or in other words stars that become very close to being like the Sun. So what we're going to do is we're going to look at stars by different categories, and the first category is stellar class. The Sun's stellar class or designation is, as I've already said, G2 main sequence, and it's actually quite incredible that many of you will know that the nearest star to the Sun, within its own category of course, is actually the second nearest or third nearest depending on the year. That's Alpha Centauri A, or as it's now known, Rigel Centaurus. Alpha Centauri A is quite strange in the fact that it is larger and more massive than our Sun, at 1.1 times its mass and 1.5 times the luminosity to be precise. But its designation is the same, G2 main sequence. And of course this means its temperature is very similar, slightly hotter this time at 5891 Kelvin. It does seem quite strange though that Rigel Centaurus is slightly younger than our Sun, which could explain why it's not hotter at this point, which you might expect of a more massive star. Next, by metallicity, we mean the abundance of heavier elements than hydrogen and helium, and if a star has a negative metallicity, it has less heavier elements than the Sun, whereas a positive value means it has more. We see here in this table that interestingly, the most Sun-like star within reason again, incredibly, is the second, or again third depending on the year, nearest star to us, the K-dwarf of Alpha Centauri B or Ptolemy, which is thought to have slightly more heavier elements than the Sun, and a figure of plus 0.12. It is quite incredible, isn't it, how similar so far the nearest star system is actually to us, and dare I say it's almost as if it were written in the stars. What are the chances? So again, in summary, negative metallicity means fewer heavy elements than the Sun, and positive metallicity means more heavy elements. The next way we could rank the stars is perhaps one that folks might expect, and that of mass and radius. This can prove quite tricky. For example, the star of Nu 2 Lupi is a 6 magnitude G-type main sequence star located approximately 48 light years away in the constellation of Lupus. The physical properties of the star are similar to those of the Sun, although Nu 2 Lupi is significantly older. It has a mass of just 0.87% of the Sun, yet curiously its radius is substantially wider at 1.05 solar radii. Interestingly, Nu 2 Lupi also has a planetary system, but this time it's quite different to our own however, with 3 known worlds so far, which all orbit substantially closer in than Mercury in our own system, and they're all super-Earths or indeed mini-Neptunes. It's quite a curious system indeed. Anyhow, I was talking about stars with very similar masses and radii to our Sun. YBP 1194 is a class G5 main sequence star in the open cluster Messier 67, this time though about 2,890 light years from us, in the constellation of Cancer. It is about as close as you can realistically get to being a solar twin, having the near exact same temperature, mass and radius as our Sun. YBP's mass is 1.01 solar masses and has 0.99 solar radii, which is quite incredible, but that's where the similarity though ends. YBP is packed in a small star cluster, Messier 67, and within a radius of 10 light years there is as many as 500 other stars to keep it company. For comparison, the Sun has just 9 star systems within the same distance, keeping us company. YBP's nighttime skies must sure be something to see, and indeed the star is thought to have a planetary system. While we're on mass and radius, we must not forget to mention the famous binary pairing of Zeta Reticuli, famed of course in the Aliens saga. Now although both stars share relatively similar physical characteristics to the Sun, it's really Zeta 2 that's the closest, with 99% of the Sun's mass and 88% of the Sun's radius, whereas Zeta 1 has 96% of the Sun's mass and 84% of the radius. It's a really astonishing system, and it's not really a surprise the location has been the fictional storylines to many alien abduction chronicles to this day. That said, however, the two stars are somewhat deficient in metals, unlike our Sun, having only 60% of the proportion of elements other than hydrogen and helium as compared to our Sun. And interestingly, Zeta 1 has an enormously low abundance of element of beryllium. It's thought this is due to unusual interactions with its rapidly rotating protostellar cloud, or indeed mixing brought on by a period of rapid rotation during the star's youth. Another interesting one in our nearby vicinity is Beta Canem Venaticorum, also known as Chara. Chara has an apparent visual magnitude of 4.25 and is the second brightest star in the constellation of Canis Venatici, or the hunting dogs. A G0 main sequence star this time, Chara is curiously about 3% less massive than the Sun, but has a radius 12% larger and a consequently 15% greater luminosity. This star lies some 27.6 light years distance from our Sun. In our final classification for this part of the series, we can also look at stars by BV colour index. This index is a fundamental concept in astronomy that provides insights into the colour and temperature of celestial objects. The Sun, for reference, has a BV index of 0.65, meaning it is a yellow star. We can see here in this table again that the star of Nu 2 Lupi is almost exactly the same colour as our star, and ever so slightly redder. Of course, the higher the number the more red tones a star has, is the star of HD 172051. Despite its incredibly dull name, HD is like our Sun, a single yellow-hued star. This time at 43 light years distance, the star is barely bright enough to be seen with the naked eye, having an apparent visual magnitude of 5.85, and is indeed moving away from our Sun with a radial velocity of plus 37 km a second. Despite it being almost exactly the same colour as our star, and also having a very similar mass to our Sun, the star however is actually cooler and has a lower luminosity consequently. Don't forget to check back over the next few weeks for part 2 of this series, where we will look at other similarities, and indeed check back and spend some time with some favourite Sun-like stars in our local vicinity, like Tau Cetus or Alsace, also known as Sigma Draconis. Our Sun is a G-type main sequence star. There are many others like it. Our nearest neighbour Alpha Centauri A has the same stellar designation, and its partner B almost the same metallicity as our star, whereas other stars like YBP 1194 and the fascinating Zeta Reticuli 2 are almost identical in radius and mass. Other interesting stars like Nu 2 Lupi and Chara, also known as Beta Canem Venaticorum, bizarrely are less massive but do have larger radiuses, while some stars like Nu 2 Lupi or the dully named HD 172051 shine with almost exactly the same colour. Sometimes in our universe it's very easy to feel alone, but it seems for once that there are other stars out there just like our Sun, and maybe just maybe have life around them just like our own. Thanks for watching, and consider subscribing if you haven't already. If you would like to support the channel further, you could consider joining the channel, which comes with some membership perks, or alternatively buy me a coffee, and I'll link this in the description. Thanks to those of you who have already done so. Chats with 1979, and America West 90. If you have any videos or subjects that you'd like to see brought to life, don't forget to let me know in the comments below. It could just be your idea next week that shows up. Take really good care of yourselves, look after your friends and family well, and I'll see you on the next one.